In this video, we're diving into the fascinating world of the three classic states of matter: solid, liquid, and gas, and we'll explore how substances can transition from one state to another using a very handy model called particle theory, also known sometimes as kinetic theory, which helps us imagine how the tiny particles behave in each state by treating each particle like a small, solid, inelastic sphere. Starting with solids, we know that there are strong forces of attraction between the particles, pulling them tightly together into a fixed, orderly lattice structure where the particles stay locked in place, which is why solids have a definite shape and volume and can't flow like liquids. Even though the particles can't move freely, they are not completely still. They constantly vibrate in place, gently jostling against their neighbors. When we heat a solid, the particles absorb energy and vibrate more vigorously, gradually weakening the forces holding them together, and at a certain temperature, the melting point, the particles gain enough energy to completely overcome those forces, break free from their fixed positions, and the solid melts into a liquid. Now in liquids, the forces of attraction are much weaker, allowing particles to move past each other more freely and arrange themselves more randomly, but they are still close enough to stay compact, which is why liquids have a definite volume but no fixed shape, meaning they can flow and adapt to the shape of any container they are poured into. If we continue heating the liquid, the particles gain even more energy, moving faster and faster, further weakening any remaining attractions until, at the boiling point, they have enough energy to completely escape each other's pull and the liquid transitions into a gas through boiling or evaporation. In gases, the forces of attraction between particles are extremely weak to practically non-existent, meaning gas particles are free to move independently, spreading out to completely fill any available space, which is why gases have neither a fixed shape nor a fixed volume. We often describe gas movement as random motion, though technically the particles travel in straight lines until they collide with something, like container walls or other particles, and get randomly deflected in different directions. As we heat a gas, the particles move even faster, and if the container is expandable, like a balloon, the gas will expand too. If the container is rigid, then instead the gas pressure will simply rise. Conversely, if we cool a gas down enough, the particles lose energy and no longer move fast enough to overcome the weak forces of attraction, leading to the formation of bonds and the gas condenses into a liquid. Cooling the liquid even further reduces the particles' energy until more bonds form and lock the particles into place, freezing the liquid into a solid. One final but crucial point to note is that when these state changes happen in a closed system, the mass of the substance stays the same, because the number of particles doesn't change, only their arrangement and energy levels do. However, the density does change, with solids generally being the most dense, liquids slightly less dense, and gases being the least dense of the three states. That wraps up everything for today's video. So if you found it useful, don't forget to give us a like, subscribe for more, and hopefully we'll see you again very soon.